separation is X, area is A, and material is K. All of these things are okay, no problem at all. But what will you put this heat equals to? You will put it equals to the latent heat ML. Okay. Similarly, if I am talking about what do we call the 200 degrees Celsius here and 100 degrees Celsius here. So 200 minus 100, 1.5 minus X. But what will you put that equal to? ML, that is the latent heat of steam. Fine. Now, the last thing over there, that is the if when you will basically take the ratio, the value of X will come out to be what? 1.396 meters. That's it. The value of X will be very easily there. We will get the value, and that's it. Now, a similar question like this is here. I will recommend you to try it on. Okay. These kinds of questions are very important in this particular topic. And once you are aware like how to do one type of problem, the another one is automatically done. Okay. Next topic is very simple. You have done it in very smaller grades as well. That's why I will just give you a small recap of it. Three types of modes by which heat can be transferred from one place to another: conduction, convection, and radiation. So if you are actually holding a rod and that is getting heated up, so the heat will transfer through the rod, through the particles of the rod, where particles are not actually moving, but the vibration is causing the heat to get transferred from one end of the rod to the another end of the rod. This is what we call as conduction. Second thing is convection, where the particles are actually moving like a hot air balloon, where the heat, like hot air, is naturally going up. Yeah, it's a natural tendency of a hot air to go up. Similarly, when we actually uh, when we try to heat water, so the hot water is going up, then the cold water is going down, where the particles are actually moving. That's convection. And the last thing is what? Radiation. So radiation is something which does not even require the medium to get transferred. For example, the heat from the sun is reaching up to us, even passing through the space. That is what radiation is. Very simple. Now, why am I talking about this? Because this particular thing will be used in the concept of Newton's law of cooling. Okay. Now, what is Newton's law of cooling? According to it, when we, yeah, so it states that the rate of cooling, yeah, so how quickly a body gets cooled up, it depends upon the temperature difference between the body and the surroundings. Okay. If you have a tea at 100 degrees Celsius, okay, and right now, let's say it's a hot season. It's a hot season, so temperature is 45 degrees Celsius. Very easily, it can hit 45 in Delhi, if I'm not wrong. Now the temperature difference is there, so the like the tea will become colder in few amount of time. Okay, no problem. But what if we talk about a cold season? Let's say the temperature is 6 degrees Celsius. Now the temperature difference, as you can clearly see, it's huge. It's comparatively very big. Now, because the temperature difference is big, the body will get cooled up very quickly. That is how quickly the body is losing heat. For that loss of heat only, we are applying a negative over here. It totally depends upon the temperature difference. Okay. Now, there are multiple versions of this formula, okay, which I am not recommending you to use right now. The one which I am recommending you to use is this one. That is, if you want to calculate the rate of loss of heat, this is what the formula you should use. Okay, final version. Now, how to use it is a big question. Now, very important. Have a look onto it. Over here, a lot of things you already know. That is, M is the mass, C is specific heat, K is the constant. Okay, K is constant. These three things you already know. But what is T1, T2, T0? What are these things? So in this situation, the temperature of the body is falling from T1 to T2. You can say this is the initial temperature and this is the final temperature. This is how the temperature of a body is falling. First thing. Second thing, that how much time is it taking to do that? Time T. Small t is representing the time. And last thing, the T naught over here is representing the surroundings temperature. Like how hot or how cool is the temperature of the surroundings. Now it still look like how to use the formula is not very clear. So I will show you an example. For example, in this question, if you will see, a body cools in 7 minutes. So the value of time is given to you from 60 to 40. That is, T1 is 60, T2 is 40, and the temperature of surroundings is 10 degrees Celsius. Now, if I want to know what will be the temperature of the body after 7 minutes, so what is that? This is how we'll use the formula. That is, MC T1 minus T2 is equals to K T1 plus T2 by 2 minus T0. Now you know all the values. We are starting from 60, then the body cools down to 40 degrees Celsius. How much time it takes? 420 seconds, 7 minutes. Okay. Whereas at the same time, the temperature of the surroundings is 10. Now, using this formula, as you can say, see that this is not only one formula over here, there are two parts of this formula. Hmm? Right now, I am using this part over here. This equals to this. Now, if I'm using this part of the formula, then I can apply it again. How can I apply it again? In the second case, in the next 7 minutes, so the starting temperature will be 40 degrees Celsius. Surroundings is still 10 degrees Celsius. How much will be the temperature of the body after 7 minutes, or we can say 420 seconds? So initially it's 40 minus T2 divided by 420. Again, the same thing where T2 is unknown to me. In the previous case, T2 was known, but now T2 is unknown. You can take this equation. You can take this equation. You can simply take the ratio of them. And when you will take the ratio, you will see that MC, MC, K and K will simply get cancelled out. And you can very easily calculate that in the next 7 minutes, the temperature of the body is becoming 28 degrees Celsius. I want you to understand few things over here. That the body's temperature is going from 60 degrees Celsius to 40 degrees Celsius in the first 7 minutes. 7 minutes. Then it is going from 40 degrees Celsius to 10 degrees Celsius in the next, what? In the next, oh, sorry, I'm really sorry. 40 degrees Celsius to 28 degrees Celsius in the next 7 minutes. Okay. Clearly, the decrease over here was 20 degrees Celsius. And clearly, the decrease over here is only and only 12 degrees Celsius. Why am I saying something like this? Because as the difference becomes smaller and smaller, the cooling down of a body also becomes smaller and smaller. That is, the temperature of the surroundings is 10 degrees Celsius. Okay. Now, if we compare this with this, you will see that when we compare 60 degrees Celsius and 10 degrees Celsius, you will see, yeah, you will actually see what? That there is a clear cut decrease of 20 degrees Celsius in 7 minutes. So difference was big, body is cooling down very quickly. But in the next 7 minutes, it's less. So this is what you have to understand. Very, very important. A similar question like this one, okay, a very, very similar question. I would recommend you to try out this one. Okay, next thing is black body radiation. Now, to understand this, I will give you a basic idea. In smaller grades, we learned that if you are able to see something, the reason behind you can see something is that it is reflecting the light which is falling on it. Okay, it's kind of a true, but the reality is when a body, like when the light is falling on a body, the light is actually getting absorbed. Okay, because light is a kind of a radiation, so it is slightly absorbing the radiation and then emitting the radiation to your eyes, and that's why you are able to see it. Okay, now this is something which is happening with all of the bodies. So every body in this world is either attracting some sort of radiation or radiating some radiation. So it is taking radiation, giving radiation are all at all the times. By the term radiation, you should not get confused. Even light is a radiation. From there only we come up to the concept of black body radiation, that black body is considered to be a perfect body. Perfect means it is actually taking all the radiation. If you give, let's say, 10 radiation in terms like simply a number, so it will absorb all the 10 radiation at the same time, and at the same time it will emit all the like after absorbing 100% of it, it will radiate 100% of the radiation as well. So black body is a perfect body which absorbs and emits 100% of radiation. This is the simple meaning. Next thing is what Stephen's law and Stephen's Boltzmann law. So exactly it is based on the concept of black body radiation only. So okay, I'm saying the body, like something is emitting a radiation or something, that's okay. But how much energy is radiated per second per unit area? Imagine I am talking about a certain area like this one. On this area, how much energy is being radiated in a given amount of time? That is what we call as Stephen's law. Okay. So the value is equals to sigma t to the power 4, where sigma is a constant which you don't need to remember. Okay. Sigma, the Stephen's constant, you don't need to remember. It will be given to you in the question. So don't worry about it. For example, have a look onto this question. Calculate the temperature at which perfect black body radiates energy at the rate of, at the rate. So the rate is given to you. Then the Stephen's constant is also given to you. We have to calculate the temperature. Formula is T is equals to E by sigma to the power 1 by 4. Basically, this is the formula. We are calculating the temperature out of that only. Now, simply just take the ratio of energy and sigma, you will get the value of temperature. Very simple. Because this is a kind of forbidden topic, means like this topic is not very famous, not very repetitive in exams. So the chances of this coming in exam is very less. That's why the questions are also easy. And that's why people ignore it. And when they ignore it and when this comes, they feel like, oh, it was so easy. Why I left it? I should have done this topic. So it's a easy topic. Questions will be very, very easy. So you just need to understand how the formula works. That's it. Now, the similar law over here can be written in two different ways. That is Stephen's Boltzmann law. So, if you are placing a body in a enclosure in an environment, and the and temperature of the environment is T naught, then this is the formula. So if you will see this formula and this formula, there is not a big difference. In this one, there is no T naught because we are not considering the temperature of the environment. But if we consider that, then this becomes the formula. Yeah. And the last thing is this particular formula, which is very, very less used actually. But over here, you will see a word very small known as emissivity. Now, how will you define emissivity? It is defined as the ratio of energy radiated. So you take the energy of the body, yeah, and you actually compare that energy with the energy radiated by a perfect body, that is the black body. So when you compare the emissivity, basically the energy radiated by a normal body, let's say any green body, you are comparing it with black body. So the ratio is known as emissivity. It's like relative density. When you are comparing the density of water with respect to the density of any other thing. So any other thing with respect to water, that is relative density. It's like that only. So everything is same. You just add the factor emissivity as well as area into time. That's it. So this formula is not actually all about per unit area, per unit time. That's why you're multiplying by area and time. Fine. Now, so related to that, you can actually see very, very easy problems. And finally, the last part of this chapter, that is Wien's displacement law. Now, of course, as you know, if there is energy corresponding to that, there will be a wavelength. If you want to calculate the wavelength emitted by a black body, it is very simple, equals to B by T, where B is the Wien's constant. That's it. Again, Wien's constant, you don't have to remember, but the formula is very, very easy, very simple. So that completes the chapter. This chapter is done, very easy. I will recommend you to do this properly so that you can score 100% from at least from this chapter. So these easy chapters should always be targeted more frequently as compared to the other chapters. So that's it. We will meet again in the next class. Till then, bye bye. Thank you so much. Bye.